Okay, this is a video on angular and linear momentum. So, it's also called angular and linear velocity. And this is how it goes. This is my third time making this video because I keep messing up somehow. Plus, this is a phone that doesn't really fit my stand. I got a new phone since the last time. So, we'll see how it goes this time. If you have a circle, here is a circle, and it's got some radius that we will call r. If you consider a point on the end of this circle, and let's say it's traveling around the circumference of the circle, you can talk about a couple of things. If it's traveling around, it covers a certain amount of distance. So if it's traveling around this way, let's say, then it's covering the outer edge of the circle, which is called arc length. Like if it covered this much of a angle, then it would have an arc length, S. But if it continually rotates around the circle, then you can also talk about the amount of distance it covers, which is S. If you recall, arc length S is equal to the radius times the angle it encloses. So you can talk about the amount of distance it covers, S, per unit of time. So that is what linear velocity is. V is how it's symbolized, is equal to the amount of arc length it covers per unit of time. Now, we also know that S is equal to R times theta, so you can also think of it as R times theta over T. But this is linear velocity. Now, if you're interested in knowing how many degrees it's passing through per unit of time, or how many radians it's passing through per unit of time, that is what we call angular momentum. Angular velocity, or momentum, we'll call it velocity, is symbolized by this kind of weird looking W, which is called omega. So angular velocity is how many degrees you pass through per unit of time, or how many radians you pass through per unit of time. Now, if you look at the linear velocity formula, it says R is equal to theta over T. This little theta over T is what omega is. So sometimes they have an alternate, we use an alternate form of this formula. Linear velocity is equal to R times omega. That noise is our new puppy, which I showed you guys a picture of, making a mess in my room while I make this video. I'm just going to ignore him. Okay, right now is a problem we're going to do. This is on linear velocity, and it says, an electrical wind generator has propeller blades that are 5.00 meters long. If the blades are rotating at 8 pi radians per second, what is the linear velocity of a point on the tip of one of the blades? So if you consider some wind turbine out in a field rotating around, making energy, and it says the blades are 5 meters long. So it's going to rotate in this circle right here, right? And so the blades are 5 meters long. That is the radius. The radius is 5 meters long, okay? And then it says they are rotating. How fast are the blades rotating? They're rotating at 8 pi radians per second. Let me write that down. 8 pi radians per second. And if I look at the units there, that's going to tell me what this is. Radians per second is a measure of angular velocity. So omega is what they gave me here. Omega is equal to 8 pi radians per second. So what I know is they asked me to find what is the linear velocity. So we said V is equal to what? But if we look at our little formula that we figured out a minute ago, V is equal to R times omega. So V is simply equal to 5, which is R, 5 meters, times omega, which is 8 pi radians per second. I'm just not going to write the radian part. I'm just going to write the 8 pi. That's 40 pi meters per second is what that ends up being. And if you multiply that together in your calculator, you get that the angular velocity, the linear velocity, is equal to, I already did this one, so hang on a second. 125.7 meters per second. That is the linear velocity. And that's the problem off of our worksheet right there. Now we had another problem on our worksheet I want to talk about called that had to do with angular velocity. So we're going to look at that one. Here it is, angular velocity. It says a point on the end of a 6.0 inch diameter wheel is traveling at 75 feet per second. What is the angular velocity of the wheel in radians per second? So we have this point, this wheel. Okay, it says the diameter is 6 inches. So all the way across the circle through the center would be the diameter, which is 6 inches. What that means is that the radius, r, is 3 inches. So they told us that. And then they said a point on the end of it is traveling at a certain linear speed. They gave us the linear speed is equal to 75 feet per second. So there's a little bit of an issue here because the units are not agreeing. We have something in feet and we have something in inches. So let me see if I can fix this. The way I folded this is making it annoying, so hang on just a second. Okay, there. So this is what we got to figure out. It says, what is the angular velocity of the wheel? So we got to figure out what is omega. Omega is equal to what? Well, we have a formula that V is equal to R omega. If we need to know what omega is, we could divide both sides by the radius, and we could solve for omega. Omega is equal to V over R. And that's what we have here, V over R. But we just got to convert this to feet. 3 inches, there are 12 inches in 1 foot. And so this is called dimension analysis, when I write all the dimensions out and I cancel these. So I know I did it correctly. So I get 3 over 12 feet, or 1/4 of a foot, or 0.25 feet. That is what the radius is. So when we put this in this formula here, we get V, which is 75 feet per second, divided by R, which is 0.25 feet. The feet are going to cancel. And we're going to get, when you put this in your calculator, 75 divided by 0.25 is 300 radians per second. We know that this is going to be in radians when we are using that formula. So that is the angular momentum. I want to say one more thing about angular momentum. Sometimes they will ask you to find something and they'll give it to you in terms of revolutions per second. So if they say, for instance, let's just take let me just draw a little box outside of our examples that we had in class. What if they say 60 revolutions per second? They say something's traveling at 60 revolutions per second. Well, a revolution means to revolve, or how many times it goes around a circle. So if we think about this, here's a circle. If I start here and I go around 1 time, that's 1 revolution. 2 revolutions, 3 revolutions. That's what a revolution is. So how many degrees are in 1 revolution? 360. How many radians are in 1 revolution? 2 pi. So if we need to use these formulas and they present you with revolutions per second, they have given you basically angular momentum. To convert it, you're going to say, let me write it like this, 60 revolutions per second. To convert it, you say how many radians are in 1 revolution. There are 2 pi radians in 1 revolution. And so you can solve for this. And so if they said something's traveling at 60 revolutions per second, you can convert it, and that's really 120 pi radians per second. And that is a form of angular momentum. So if they give it to you in revolutions per second, you can figure it out that way.